Good day, students. So welcome again in our one video. So today we will tackle about making inference on two populations, which is about the test of difference. So in this module, so we will discuss the two types of t-test, which is t-test of independent samples and t-test for dependent samples. Okay. So our learning competency in this module. So use statistical techniques to analyze data, which is about the study of differences limited for bivariate analysis. Okay. So introduction: in every problem there must always be an answer. To achieve this answer, there should be appropriate tool to be used in addressing a problem. In a quantitative research, these tools refers to statistical technique, which is used to analyze the collected data. Treating the data statistically is considered to be the concluding part of the research procedure, as find answer to the research question and hypothesis. So we call this process as testing the hypothesis. In this stage, the researcher may examine his or her study whether a predictor variable has a significant relationship with the outcome variable or when two or more groups have significant difference. So this module focuses on the study of the differences of two populations. So for instance, a researcher wishes to compare the growth of a plant using two different kinds of soil, or a teacher wanted to find difference on the scores on her students in pre-test and post-test. So these inquiries will introduce us to statistical techniques that uses independent sample t-test and the paired sample t-test. So these types of t-test, we'll use this in our research. Okay. So let's go to our topic. So making inference on two population means, so test of difference. Study of differences deal with understanding that the dependent variable may be different or not based on a group of observations. So in this, we will use a comparison test that can test significant differences of two or more populations on a specific dependent variable. This can be either parametric or non-parametric tests based on the assumptions being met. So parametric tests give stronger inferences for the data than non-parametric tests. Common parametric comparison tests are the t-test, which has two types. We have the paired and independent samples, and the ANOVA. Okay, so below is a roadmap for inferences concerning two populations of study of differences. Okay, what is t-test? A t-test is a parametric test of difference between the means of two groups. It is used to test the null hypothesis that there is no significant difference on the two group means, or it can be used to determine the effect of an employed treatment to the population of interest. T-test as an inferential statistic follows basic assumptions to other parametric tests such as independence of observations, homogeneity of variance, and normality of data. So this t-test uses t-distribution table to determine the critical value and the p-value of the computed t-value. This module will only focus on two kinds of t-test, which is the paired sample t-test and the independent sample t-test. Okay. So when to use t-test? So we want to use t-test to test the significant difference of two groups, two group means. So we choose t-test provided that the dependent variable is continuous. The following are the other assumptions that classifies the types of t-test. So paired or paired sample t-test or the independent sample t-test. Okay, so there's a table. So types of tests, we have the paired sample t-test. So the characteristics or the assumption, it is used to determine whether the mean difference between paired observation is statistically significant or different from zero. Okay, so one independent variable that consists of two categorical related groups or matched pairs. So this is the formula. T is equal to, so this is the difference, divided by the standard deviation then divided by square root of n. So where d is the mean difference, s the standard deviation of the difference, n is the sample size, and df is the degrees of freedom, which is n minus 1. So example here of the categorical variable. So we have the weight before and after the closing program. Okay. So this is for the paired sample t-test. Usually this is used when we are going to test a difference, like pre-test, post-test, or we have a experimental research, like for example the growth of the plant. So we're going to compare the difference of the two plants. So you will use the paired sample t-test before and after. Then we have now the independent sample t-test. It is used to determine if the difference exists between the means of two independent groups on a continuous dependent variable. So one independent variable that consists of two categorical independent groups. For example here is the compare the grade point average statistic between male and female. Okay, so remember the variables needed here. We have, so for our independent variable, so it's either categorical variable, so it could be gender, example male and female, so compared to their example weight or height. Okay, that is your dependent variable. Then we have the formula. So the formula for independent sample t-test is t is equal to, so the mean 1, so m sub 1 minus m sub 2 divided by square root of, so this is the standard deviation 1 squared, the standard deviation 2 squared, so divided by n sub 1 plus n sub 2. Okay, so just remember this formula to guide you in computing the t-test for manual. Later I will also discuss how to do it using the JAS software. Okay, just like what we did in our previous discussion and test of correlation. Okay, so how to use t-test in research. So now that you are familiar with the type of t-test as differential statistical tools, this time we will apply your understanding on testing the significant difference on two group means. Okay, so the following can be used to analyze the data. Number one, we need to show the statistical computation of the descriptive and inferential statistics. 2. Interpret the results and findings of a study based on the statistical analysis outcome. So decision rule for classical approach when the alternative hypothesis is two-tailed. Okay, so computed t-value. So if our t-value is negative, so we will reject the null hypothesis if our t is less than the tabular value, okay, or the critical value. So the table can be found on the appendices in this module. Okay, so remember for negative, so if it is less than the critical value or tabular value, so you will reject the null hypothesis. Then for positive t value, it is greater than the critical value or tabular value, so you will reject the null hypothesis. Then the interpretation there is, so it is significant, or the difference is significant. So if you use the JAS software, you just look at the p-value. So if the p-value is less than 0.05, so it means our t-value is significant. Okay? Okay, so note, critical values can either be positive or negative. So hence, when the difference between the sample means is negative, then use the negative critical value. So otherwise, the positive. Okay, so take note of that in the table. And how to report the findings. So to report the findings, consider the template below. So test, type, and use. So independent sample t-test was used to compare. So you write your DB. So between, then your IB, then condition 1 and IB condition 2. Then significant difference between conditions or group. the difference of the DB measure and IB level. So you need to write the mean, the SD, then the IB, independent variable level, the mean SD the same. Then what's the result, significant or not? Then you write the t value and degrees of freedom here and the critical value. Okay, so let's apply this. We have this task 1. Let's have this example. So is there a significant difference on the awareness of risk level towards COVID-19 between male and female? So given the following data, use a 5% level of significance. Okay, so take note. So we have here a categorical data or variable, which is the gender, which is male and female. And we will going to test if there is a significant difference on their level of awareness in COVID-19. Okay, so to do that, so let's analyze first. So what we're going to use here. So later, so since this is a we have a independent variables which is categorical, and we have a continuous dependent variable is continuous. So in here we will use the independent sample t-test. Okay, because we are not having here a pre-test and post-test. Okay, so that is your clue on what type of t-test to use. Okay, so it's categorical, so you can use independent sample t-test. Okay, here's the computation. So first you need to compute the mean of the male and female. Okay, so our total here is 65. Here's our values here for male. Then we need to get the mean. So here our mean is 3.82. So here's the computation for mean. So 65 divided 17, total of male, which is 3.82. Then SD, I will put later SD. So here is the difference now. So subtract the mean, which is 3.82, individually to the value of x. So 3 minus 3.82 is 0.83. Then 4 minus 3.82, 0.17. Until you reach all the x up to this last row, 5. Okay? So that is the difference between the mean, from the mean. Okay, then in this next column, so we will now get the square of this answer here. So 0.82 square is 0.69. So you do the same and the rest of the rows here. So you just get the square until you reach the last column. Then you get the total of it. So the total is 8.47. After that, you will now get the standard deviation. So 8.47. So you just follow this formula. Square root of the absolute value of x minus mean squared divided by n minus 1. So our computed square of the difference is 8.47 divided by 16. So our n here is 17. So 17 minus 1, 16. And you get the square root. The answer of standard deviation is 0.73. This is for the male. Now the same process goes to female. Okay, for female, so the same. You get the mean first. The mean is 3.60. Okay, and subtract it again to these values here in this first column. So 3 minus 3.60 is 0.60. Then so same procedure until you reach the last number. Okay, then again, so you same process in here. So get the square of this value. 0.60 square is 0.36. So you just follow the same procedure, square these answers here. So to get this portion here. Okay. Then you get again the sum of this column, which is 7.60. After that, you can now compute the standard deviation for female. So the same procedure. So just substitute in the formula. So our absolute value of x minus the mean squared is 7.60 divided by 14. So then get the square root. The answer is 0.74. Okay. So I hope it's clear to you. the main and SD computation. Then after that, so let's have this table. Okay, so let's analyze. So based on your hypothesis, so our null hypothesis is there a significant difference on the awareness level of towards COVID-19 between male and female? So our HO here is there's no significant difference on the level of awareness towards COVID-19 between male and female. Then let's decide what statistical tools to be used. The statistical tools to be used is the independent sample t-test, since a dependent variable is measured in continuous and the independent variable is a categorical data, okay, which is unrelated samples, so it's gender, male and female. Okay, so that is your clue on how to use if it's the independent sample t-test or paired sample t-test. Okay, then let's summarize that data in this table. So for male we have 17, female 15, our n, then our computed mean and SD in our previous example. So T, this is the formula now of the independent sample t-test. So just simply substitute these values. So you will get here T, which is 0.862. Then, so at the back of this module, you will have the tabular value of this t-test here, which is 2.04. So the degrees of freedom here is 30. Okay, you just add the 2n, which is 17 and 15. So then minus 2, which is, so we have two groups, so 30. Okay, so let's check if we will decide now if it's we're going to reject or accept the null hypothesis. Okay, so decision. So the null hypothesis, there is no significant difference on the awareness level towards COVID-19 between male and female is not rejected since our t value is less than the critical value. So remember the table we discussed earlier. So if it is positive, so it should to reject the null hypothesis, our t value should be greater than the computed value, the tabular value, which is 2.04. So how do we get that value 2.04? So just look at that in the table. So this is the table. So our df here is 30. Okay, so degree of freedom is 30. So then our test is 5%. Okay, so I hope you can see it clearly. I'll just have the full screen. So here is 30. This is our t value, which is here, the 2.04. Okay, so I hope you get the idea on how to use the table. Okay, so I hope it's clear to you. Okay, so let's now apply this using the JAS. Okay, let's compare our result. We get the same answer. Okay, so in JAS, so we have here the same. We have here the same data. Okay, so how to summarize the data? So you need to summarize the data in this format. So you write here the gender. So first you need to write this in Excel. Type this in Excel. So in this format. So first column gender, you put gender, then the score. Then female, write the word female and the score 333, then male. Okay, so type it in Excel, then you save it as CSV. Okay, then you run it in JAS. So the same in our previous module in test of correlation. Okay, so I hope you get how to have your data set up in just. So the same with correlation. So again, you need to type it first in Excel in this format. Then you need to save it as CSV file. Okay, CSV comma delimited. Okay. After that, so this is our data. You need to go to TTest. Then go to independent sample t-test. So here we have this, we have here variable and we have the grouping. So need to grouping. This is our independent variable. So how do we group our variable? So we group it according to gender. So we put gender here. Okay, then our variable here is a score. Okay, so just ignore this. Okay, then if you're going to determine the location parameter and the effect size using the cohens D. Okay, so I'll just maximize the screen. So you can see the result and cohens D. Okay, so I hope it's clear. So here we have the same answer. Now, okay, just ignore the negative sign here, which is 0.862. So which is the same in our computation. And the freedom is 30. So their p-value here is 0.395. So as I said earlier, it is greater than 0.05, it is not significant. So therefore, so the difference between COVID level awareness between male and female is not significant. Okay, you can also see here. Okay, their difference is negative 0.224. Then the cohens D. So what is cohens D? This is a measure of the effect size. Okay, of the difference. So since this is negative, so it is negligible. Okay, effect size. Okay, so I hope it's clear to you how to get the event sample t-test using the JAS. Okay, okay, let's go back to our module. Okay, let's now have this example 2, the report. Okay, so how to report the findings. So in your research paper, so the following will be the format. So this is a table in reporting your findings. So you need to have, you need to gather the mean, then t-value, then the critical value, then the interpretation, if it's significant or not. Okay. So you can also gather this data in JAS. Okay. So I'll just let you how to. Okay, let's go back JAS. So you can have here the descriptives for the mean. Just click this. The same. Just copy this because you need this in your table. Okay. I hope it's clear. Okay, so this is now our interpretation or reporting of findings. An independent sample t-test was used to compare the level of awareness towards COVID-19 between male and female. The difference in the level of awareness towards COVID-19 of male is, so the mean here is 3.82. Okay, then SD is 0.73. And female, 3.60 and SD 0.74. Then, what is the result? It is not significant. Okay? So, anyway, this is not significant. So, this is an error. So, let me change it. This is not significant. Okay? So not significant. Okay, so our critical value here is 2.04. Okay, so based also on the just, so we counter check it, so we found it is not significant. So based also on the cohens D. Okay, so I hope it's clear to you how to use the independent sample t-test. So let's now go to the dependent sample t-test or the paired sample t-test. Okay, let's have this example. So as our state of the problem, is there a significant difference on the growth of plant before and after applying organic fertilizer? So our null hypothesis here is there is no significant difference on the growth of plant before and after applying the organic fertilizer. So we have here the data here. So our alpha here is 0.01. Okay, so here our data before and after. Okay, so you can again type this in Excel. So you put before and after, then save it in CSV. Okay. Okay, we have here. So below is the descriptives. So the same procedure, just like we did earlier. So first, compute first the mean. Okay, because we need to get the mean and ST, same process. So mean is 2.12. Okay, then after you get the mean, subtract 8 to the value of x here. 2.2 minus 2.12, which is negative 0.08. Okay, 1.8 minus 2.12, which is 0.32. So subtract 8 until you reach the 10th element, 2.3. Okay, and after that, the same procedure. The third column, you need to get the square. So negative 0.08 square is 0.0064. So the same process until you complete all these numbers here. Okay, then after that, you get the sum, which is 0.596. Okay, after that, so you need to get now the standard deviation. So using this formula. Okay, so our formula here is so this is 1. So 0.596 squared divided by 9. So the answer would be 0.46. Okay, so the same in our previous example. Then we need to get the same process in female or the after. Okay, so after. So here's our after data. So the same, get the mean. Our mean is 3.73. Then subtract 8 individually here. 4.2 minus 3.73, which is 3.73. Okay, so subtract 8. Okay, then until you reach the last element. Okay, so here it should be positive. So 4.2 minus 3.73, which is positive 0.47. Okay, so let's correct this. So it should be positive. So let's zoom. Okay, so that is positive. Okay, so just subtract the values. Okay, so we have some errors in our module. So this is still positive. 4.4 minus 3.73, so positive 0.67. So I'll just edit so you cannot be confused with the result. Then, so the same procedure. So here, so this is negative, negative. So I'll just check. So this is negative. Okay, I'll just edit. So here, this is negative. and here it is negative. Okay, so just counter check. Okay, just do the checking. So then you square the result. So this would be the answer, 0.00209. Okay, then get the sum. So which is 2.121. Then get the SD now. So our SD is 0.49. Okay, then we have now here the difference. Okay, so between our before and after. So we have here this guide y minus x. Okay, or after minus before. So 4.2 minus 2.2, which is 2. Then let's go to the next. 3.8 minus 1.8 is 2. So the same process. So y minus x is y, then to x. Same procedure. Then you get the sum, which is 16.1. Then after that, so you get the mean of this deviation. So then the same procedure, subtract it from the mean difference of this column. So 2 minus, which is the mean difference, is 1.61. Okay, look at this value. So subtract it, same process in our before and after. So 2 minus 1.61, the answer is here. Okay, then again get the square of this part. Okay, which is 0.1521. Okay, the answer would be 1.89. And after that, you can now get the SD, which is 1.89. Okay, so RSD is 0.46. Okay, then after that, let's have this table. So let's analyze. So SOP natin is there a significant difference on the growth of plant before and after applying it with organic fertilizer? So our HO here is there's no significant difference on the growth of plant before and after the organic fertilizer is applied. Okay, so let me have first the module. Okay, hope it's clear. Okay, then still to be used. So we will use here the paired sample t-test. Why? Because the variable is continuous. Okay, and it is consists of two related samples. So before and after. That is your clue when to use paired sample t-test. Okay, you have the before and after. Okay, so here's now the summary of our data. Okay, we have, so before and after, our sample is 10. Our mean is 2.12, then 3.73 for the after, SD 0.26, 0.49. Then we will now compute our T statistic. So our mean difference, which is 1.61, and our standard deviation is 0.46 divided by square root of 10, then simplify. The answer would be 11.11. Okay, then if you look at the table of values, so our degree of freedom there is 9 and critical value is 3.25. So just look at in the appendices. Okay, so we take note, so it is at 1%. Okay, so let's look at the table. So degrees of freedom is 9, 1%. Okay, let's zoom. So we have here, so 1%. So we have here a 9, which is let's look at, so it is here 2 point it is 3.25. So our critical value here is 3.25. Okay, hope it is clear how to use the table of values. Okay, so I hope it's clear. Okay, then so let's check if it's significant or not. So since our t value here is greater than our tabular value, which is 3.25, so our decision here is to reject the null hypothesis. Okay, because it is significant. Okay, so decision, the null hypothesis that there is no significant difference on the growth of plant before and after applying fertilizer is rejected since the t value is 11.11. 11.11 is greater than the critical value 3.25 at 1% level of significance. Okay, so I hope you get the correct answer and computation. So let's counter check it using the JAS software. Okay, so let's check. So same procedure, you need to type it in CSV, a file. So type it in CSV, then after that save it as a CSV file. Okay, so it's still loading. So I will have now the JAS. Okay, let's wait for JAS to load. Okay, so here's our data. So you type it in Excel. So CSV in this format, before, then after, type the values. So I have our n, which is 10. Okay, so you go again to t-test, go to paired sample t-test. So our variables here, so you look at the paired sample is variable pairs. So put values here. Okay, so you can have the effect size also and the descriptives to aid you in analyzing the Okay, so I hope you can see it in the table. So I'll just maximize a little. Okay, so here we can see the result, which is so the same. So we computed 11.113. Okay, so you can look at the p-value, which is less than 0.01. So it means it is significant. Okay, so take note of that. Then our descriptives here. Okay, then our coherence D is negative 3.51. Okay, so I hope you get the process on how to compute using the JAS software, using the paired sample t-test. Okay, so let's now interpret the result or report the findings. So we have this table, so just follow this table. So difference on the growth of plant before and after. So we have the groups before and after. So you just write the mean, then t-value, then critical value, then decision. Okay, so reject HO. Then this is now our discussion here, reporting of findings. Paired sample t-test was used to compare the growth of plants before and after applying the organic fertilizer. The difference in the growth of plant before M, so our mean here is 2.12, so you can see this table, and SD, and after the mean is 3.73, then 0.49 the SD, and treatment or t-value is 11.11, critical value is 3.25. Okay, so that's how to compute the test of difference using the paired sample t-test and independent sample t-test. Okay, so I hope you get the process. Okay, for your exercise, you answer this in your paper. Okay, so here, so this is the instruction. The following are the null hypotheses of a research and its descriptive statistics, and analyze the data using appropriate technique. Use a template. Okay, so here, so you're going to analyze, so using this template, so as we did earlier. Okay, so just review your module so you can be guided how to answer this. Okay, so see your data. We have 2 exercises here. Okay, then let's remember this. So t-test is parametric test of difference between the two means of groups, which can be classified as paired sample t-test and independent sample t-test. So paired sample t-test is used to compare two populations when population means when you have two samples in which observations in one sample can be paired with observations in the other samples, or related dependent samples. Then number 3, independent sample t-test is used to compare two population means whether you have two samples in which two observations in one sample is different with observations in the other examples, independent samples. Okay, then so another exercise, you answer this in your paper. Okay, so compute, so you know it, compute it. So you can compute manually, then you can counter check it using the JAS software. Okay, so I hope it is clear to you how to compute using the t-test, so for the test of difference. Okay, so if you have questions and clarifications on our topic, so you just PM me in my account.